Hey, college algebra kids. Today we're looking at exponents and scientific notation in college algebra with Mr. Forbes. Notes out and away we go. We're looking at integer exponents and scientific notation. Again, largely a review from from Algebra 1, Algebra 2. First, let's recall where exponents come from. So let's say that we have a variable x. We're going to multiply x times x times x times x times x. Well, how many x's do we have, right? These are each x to the first power. Well, there's 5, so we're going to add the exponents, which is x to the 5th. We're going to say the x is the base. The 5 is the exponent. Also recall that if we have a negative exponent, it's going to reciprocal the base. So here we have x to the negative first over 1. That negative 1 exponent is not a negative in front of the term. It's the exponent. What that's going to do is it's going to flip the base to the other side of the fraction. So it's going to turn it into 1 over x. For example, m to the negative third, again, same thing. This is a fraction over 1, and we're going to flip it to the other side of the fraction. It's in the numerator, so that means it's going to go to the denominator. Lastly, we have something in the denominator, 1 over a to the negative second. That's going to flip it back to the numerator to become a to the second. So there's negative exponents. Here's our rule for negative integer exponents. If a is a non-zero real number and n is a positive integer, then a to the negative n is 1 over a to the n. So there's two ways we can think about evaluating these. For example, here I have a fraction, 2 over 3 to the negative second. The first way to evaluate this is to think about flipping first. So because this is a negative, 2 in the numerator is going to go to the denominator. The denominator is going to go to the numerator, right? We're going to reciprocal. And so this becomes then 3 halves squared. So that took care of our negative. The negative, again, reciprocal is the base. Now we want to square each side. 3 times 3 is 9. 2 times 2 is 4. So there's one possibility. The other way to think about this is to go ahead and square first, then apply the negative. So if we go ahead and square, we can square 2 and 3 to get 4 and 9. But we're still left with the negative 1. We can flip that, and again, that becomes 9 fourths. You can also do this on your calculator as well, but you'll need to practice this because you can't do variables. So this is our practice for when we get to variables. We have rules for negative exponents. Again, here's our basic rule. Anything to the negative first power becomes a reciprocal, 1 over a. The reverse is true. If 1 over a to a negative power, then that takes it from the denominator, the base from the denominator back to the numerator, a to the positive n power. A to the negative n, then again, if we have something that is not a 1, it works the same as 1 over a. We can do a quantity n. And then b, again, this is like our fraction example. If we have a over b to the negative n, the negative exponent is going to flip the fraction. So now we have b over a to the power of n. Later on, we'll see that then this is actually going to be b to the n over a to the n. That's a little bit later, but that is equivalent. So let's use those rules to evaluate these exponents, or powers. They're really powers. So here we go, 3 to the negative first. That's going to be our first rule, 1 over a. This becomes 1 over 3. Sends it from the numerator to the denominator. B, we're in the denominator. We're going to go back to the numerator. That's 5 to the third. When you're doing the homework, make sure you read the directions. Sometimes they'll say leave it in exponential form. If it doesn't, go ahead and multiply it out. 5 cubed is 125. 3 to the negative second. Again, the negative exponent flips it to the denominator. So 1 over 3 squared. Again, we can multiply that out. That's 1/9. Negative 3 to the negative second. Again, can't state this enough. The negative exponent has nothing to do whether the number is positive or negative. Here we have a negative, it's squared, so we're going to do this step by step. The first thing we're going to do is flip this to the denominator. This is 1 over negative 3 quantity squared. Negative 3 quantity squared is negative 3 times negative 3. The negatives have to cancel, so we're left with a positive 1/9. If you type that in your calculator, make sure you type it in the way it looks. How's this one different? Well, this one doesn't have the parentheses, so this will also flip 1 over, but there's no parentheses, negative 3 squared. How's this one different? Well, this is 1 over negative 3 times 3. Only the 3 is being squared, not the negative. So there's only one negative. That means our answer has to stay as negative 1/9. In letter D, because there were parentheses, there were 2 negatives, 1 for each 3. Those negatives canceled, become positive. E, there's only 1 negative because there are no parentheses. Very different problem. Ask me if you don't quite get that. Letter F, we're going to cube this and flip it. So I'm going to actually flip first. So that's going to be 4/3 cubed. Here we need to actually cube the top and cube the bottom. We'll get to that rule in a second. 4 cubed is 64. 3 cubed is 27. More rules. Again, I hit on this one more time. Remember the difference between negative 3 squared and quantity negative 3 squared. Negative 3 squared is just a negative times 3, which is negative 9, versus negative 3 squared is negative 3 times negative 3, which is positive 9. Two very different ideas. Make sure you grasp that one. Now we get into a bunch of the rules. What if we're multiplying with the same base? If a is not equal to 0 and m and n are integers, then we can, if we're multiplying a times m times a to the nth, that's just a as the base, and then we're going to add the exponents, m plus n. If we're multiplying the base, we add the exponents. And really multiply the same base, add the exponents. So simplify each expression, write answers with positive exponents. We're not going to multiply these out unless they're small multiplies, we can do that. So 3 to the 4th times 3 to the 6th, this becomes 3 to the 4 plus 6, which is 3 to the 10th. That's a really big number, so again, we're not going to multiply that out. We're just going to leave that in exponential form. Letter B, we're going to multiply. We can multiply 4 times 5. That's easy enough. That's 20. X to the negative 3rd, x to the 1 becomes x to the negative 3 plus 1, which is 20, x to the negative 2nd. And then we want to write that with a positive exponent. So this becomes 20 over x squared. Note, the 20 has a positive exponent as a 1. It doesn't move. It stays in the numerator. The x squared is the only one that goes to the denominator because it has a negative exponent. Letter C, we want to multiply first. So negative 2 times negative 5 is 10. We're going to add the exponents. Negative 3 plus negative 4 is negative 7. As we saw in the previous problem, the 10 has an exponent of positive 1. It's staying in the numerator. The y is flipping to the denominator as y to the 7th. Next rule, 0 exponent. If a is any non-zero real number, then a to the 0 is equal to 1. Simplify each expression, write answers with positive exponents. A is a trick problem, and you're going to think I'm wrong, but go ahead and check it on your calculator. 0 only applies to the base, not the negative, because this is really negative times 3 to the 0th power. So 3 to the 0 is 1. We're left with a negative 1. For that to have all gone to 0, it would have had to have been -3 quantity to the 0th power. That would go to a +1. Big difference on where the parentheses are. Letter B, doesn't matter what it is, 1/4 minus 3/2. We're gonna do that subtraction, we'll get a fraction, doesn't matter, it all goes to the 0th power. Anything to the 0th power is 1. Letter C, now we get into some bigger problems. We're gonna multiply the numbers, add the bases, exponents of the bases. So -2 times 3 is -6. That leaves us with a to the 5 plus -5, b to the -6 plus 2. And that's going to give us -6, then a to the 0, b to the -4. And we're going to simplify that. A to the 0 goes to 1. And so we're left with -6 in the numerator. B to the -4, again, -6 has an exponent of 1. It stays in the numerator. B to the -4 flips to the denominator. So -6 over b to the 4th. Then we can start getting into some bigger problems like letter A. Write each expression without negative exponents and simplify. So there's a couple ways you can do this. One thing you can do first is to write everything in terms of positive exponents. So again, 5 has a 1, a has a negative, a squared is positive, 2 it has a -2. So we're going to rewrite everything with positive exponents. So 5 to the first stays in the numerator. A cubed flips to the denominator because it had a negative exponent. A squared has a positive exponent. It stays in the denominator. 2 to the second goes to the numerator. And then we can simplify from there. 2 squared is 4. 4 times 5 is 20. A cubed, a squared, we're going to add the exponents. So if we're multiplying the bases, we're adding the exponents, is a to the 5th. B, again, let's look at positive exponents first. -2 has a positive exponent of 1, so it's staying in the numerator. X has a negative exponent, is flipping to the denominator as x cubed. Y goes back to the numerator as y squared. Z has a positive exponent, it stays z cubed. None of the bases are the same, so we can't do anything. We're done there. Next rule is the quotient rule. Quotient rule says if m and n are any integers and a is not equal to 0, then if we're dividing the bases, we're going to subtract the exponents. So a to the m over a to the n, if we're dividing the bases, we're going to subtract the exponents. Multiplying the bases is add, dividing the bases is subtract. Let's look at some examples. We're going to write, again, answers with positive exponents. That's in exponential form. Here we go. So 2 to the 9th over 2 to the 4th. This is going to be 2 to the 9 minus 4. If we're dividing the same bases, we're subtracting the exponents. That's 2 to the 5th. Letter B, same thing with variables. Doesn't matter if it's negative, still works the same way. This is m to the 5th minus a -3, which turns into positive, and that's m to the 8th. What you're going to find is with a lot of these problems, we can do them different ways, because we can also realize that this is m to the 5th times m to the 3rd. When that becomes positive and moves to the numerator, we're going to add the exponents, which becomes m to the 8th, which is what we just did. Letter C, same thing, where if we divide the bases, we're going to subtract the exponents. Y to the -4th minus a -2 becomes a +2. And that gives us y to the -2nd. We want to write the answer with a positive exponent. So we're going to go one more step and flip that back to the denominator. 1 over y squared. Again, there's other ways you could do this. We'll look at some other rules here in a second, because if we actually flip these, well, we could flip these and get y to the 2nd over y to the 4th. That's y to the 2nd minus 4th, which is y to the -2nd over 1 over y squared. So again, there's going to be several ways to think about these. As long as you're using correct math steps, you'll get to the correct answer. Then we can start combining rules. Letter A, 2 to the x to the negative 7th over x to the negative 7th. Well, we still have a rule that anything divided by itself goes to 1. Well, what happens if we take negative 7 minus the negative 7, which turns it to plus? Well, that goes to 2x to the 0, right, which goes to 1, and that leaves us with a 2. So basically, these cancel because they have the same exponents. Letter B, let's go ahead and multiply the numbers first. So we're going to have 2 times 1 is the coefficient, so that's 2. We're going to multiply the w's, w times w to the negative 4th. I'm going to do the numerator first, and then we'll cancel top to bottom, or we'll do top to bottom operations. So this is a 1. There's no exponent outside the parentheses. We're going to do that in a second. So 1 plus negative 4 is w to the negative 3rd. All over 3 w to the negative 2nd. Well, 2 and 3 both have exponents of positive 1. So that still leaves us with 2/3. Now we have w to the negative 3rd minus a negative 2, which makes it plus. That's going to give me a 2/3 with a w to the negative 1. And then that w is going to flip back to the bottom side. So 2 over 3w. So that one had quite a few steps in it, and that will happen from time to time. Later on, we'll get to bigger problems. They'll have just as many steps. Letter C, we have some choices. My recommendation here is you're going to simplify the numerator, simplify the denominator, and then we'll look to do top and bottom. Let's simplify the numerator. That's x to the negative 1st times x to the negative 3rd. We're multiplying the bases. We're going to add the exponents. That's x to the negative 4th, y to the 5th, over x to the negative 7, y squared. Now we can divide. Because we're dividing, we're going to subtract the bases. That's going to be x to the negative 4th plus 2 when we minus the negative. Y to the 5 minus 2. We'll do those operations. Negative 4 plus 2 is x to the negative 2nd, y to the 3rd. Again, x has a negative. We want to write our answer with positive exponents. So y cubed over x squared. Last thing to look at is scientific notation. Scientific notation is used to write very large or very small numbers. Distance from Earth to the sun is 93,60 miles. How do we write that in scientific notation? We're going to start with where our decimal point should be, and we're going to move it to just to the right of the first non-zero digit number. That's the 9. And then we need to include all non-zero digits until we get to the zeros. So this becomes 9.3 times our exponent becomes how many times we move the decimal point. 1, 2, 3, 4, 5, 6, 7. So we moved the decimal point 7 places. So we got 9.3 times 10 to the 7th. We're using positive exponents for big numbers, negative exponents for small numbers. For example, the weight of a hydrogen atom, there's a whole bunch of zeros. Where does our decimal point go? It has to go to the right of the first non-zero digit. So that's going to be a 1.7 times 10. Now we need to count how many places we're moving. And if you count that carefully, you should note that it's 24 times. This isn't a big number. This is a really small number. For small numbers, we're using negative exponents. You can do that on your calculator. Let's see how we can do that on your calculator. First thing I'm going to do is actually just type in the number. So 93, 123, 123 is my number. I'm going to actually change mode. So if I go to mode, and if I go to scientific, which is up here at the top, scientific, and then exit out, I'm going to hit that number again. There's my number in exponential form on the calculator, 9.3. The E takes place of times 10. to the 7th. So there's my number. This will, anytime you put in a number, if you're in scientific form, like if I put in 500, it will automatically put the number into scientific form. So if I put in 0.24 zeros, 1, 2, 3, 4, 5. And then 1, 7, then there's my 1.7 times 10 to the negative 24th. Note, you had to actually put in 23 zeros because one of the places is the 1. Make sure when you're done then, go back to mode. We're going back to normal mode on the calculator. Scientific notation then is a number written in the form a times n 10 to the nth, where a is between 1 and 10, and is a positive or negative integer. Now let's go the other direction, write each number in standard notation. This is a big number. It's a positive exponent, so that makes it a big number. That means we're going to the right. So 1, 2, 3, 4, 5. So we have a 7, 6, 2. We're going to fill in missing spaces with zeros, and that would be 3 zeros. 2 of the place values were taken up by the 6 and the 2. I had 3 left over. We fill in with the 3 zeros. And then finally, we come back with commas every 3 places. Letter B, this is a negative exponent, which means it's a small number. So we're going to the left. So 1, 2, 3, 4. That's 0 point. 1 place is taken up by the 6. That means we have 3 zeros left. And then 6, 3, 5. Again, you can also get those just by typing them into your calculator as well. Convert each number to scientific notation. Again, the decimal is going to go after the first non-zero digit, which is the 9. That's 9.34 times 10. How many places do we have to go to get there? There's 3, there's 6, and that would be 8. Letter B, the decimal goes to the right of the first non-zero digit. That's 2. That gives us 2.5 times 10. We go 1, 2, 3, 4, 5, 6 places to get there. It's a small number, so it gets a negative exponent. Example 9, evaluate without a calculator. Again, this is SAT practice. You're going to take the SAT here in a couple weeks. We can do these without a calculator because there is a non-calculator section on the SAT. How do we do that? Well, we can multiply 2 times 6.3. Then we're going to multiply, we're basically just rearranging these. This is going to be 10 to the 7th times 10 to the negative 11th. Well, how do we do that? Well, we're just going to multiply this out. So 2 times 6.3, that's just double. Double 3 is 0.6. Double 6 is 12. Times 10, we're just adding the exponents. 7 plus negative 11 is negative 4. This did ask for an answer in scientific notation, and we are in scientific notation. Letter B, same thing. We want to just do the division. 7 divided by 2. Well, 7 divided by 2 is 3.5 times 10. Because we're dividing the tens, we're going to subtract the exponents. 13 minus 6 is 7. So 3.5 times 10 to the 7th. Letter C. How are we going to do this? Well, the first thing we want to do is change this into scientific notation. How can we do that? Well, this is going to be 1 times 10. There's 1, 2, 3, 4 times. This is going to be 2.5 times 10. That's 1, 2, 3, 4 to the negative 5th. All over 5. Decimal goes at the end. Times 10 to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's negative 6. Let me double check that. Yep. Now what are we going to do? Well, let's multiply the numerator. Then we can divide. So 1 times 2.5 is 2.5 times 10. Because we're multiplying these, we're going to add the exponents. 4 plus negative 5 is negative 1. All over 5 times 10 to the negative 6. What's 2.5 divided by 5? Well, 25 divided by 5 is 5. And because we're 1 decimal point, we have to keep a decimal point in front. So 2.5 divided by 5 is 0.5. And then we're going to subtract the exponents times 10. Negative 1 minus a negative 6 becomes plus 6. Minus 1 is 5. However, that's not scientific. We have to move the decimal point down one space. So we get 5 times 10. Because we move down one space, that means we have to move down one exponent. 5 times 10 to the 4th. So it's possible to do those without using a calculator. Example 10, the weight of a hydrogen atom is 1.7 times 10 to the negative 24th gram per atom. How many hydrogen atoms are there in 1 kilogram of hydrogen? So we need 1 kilogram of hydrogen. We're going to multiply that by what? So 1.7 times 10 to the negative 24th. So we need 1,000 grams. So we need, that's gram per atom. So we're going to multiply by 1,000. Multiplying by 1,000 is really multiplying by 10 to the 3rd. So 1.7 times 10 to the negative 21st. When we add the 3, still really small. Homework. College Algebra, lesson 5.1. We're on page 302. We're doing 8 through 76, multiples of 4. Make sure you note multiples of 4. That means we're doing 8, 12, 16, 20, 24, 28, 32. All right, it's going to help you review your multiples of 4 all the way to 76. And then 78 to 106 evens. Make sure you pay attention to that. See you in class, Maroons. Have a good day.